Stream good, recording. Alright, hello world, my name is Miles. I'm the host of this Twitch channel, Miles Does Science, where every week, or I guess a couple times a week, I, a scientist, play a science theme game and try to see just how accurately it represents the science it is based on. Today I'm going to be playing some more Project Chemistry, a game that I started playing on stream yesterday, where you start from simple atoms and molecules and progressively synthesize more complicated stuff. So, without further ado, let's continue. So I've been working in quest mode so far, and I don't need this tutorial. Should have left off with what I had yesterday. Yeah, okay. It's like we have our progress saved, which is good. So, let's see. Last time, we were trying to do a couple things. Let's see. Here we go. I was trying to do this combustion reaction of iron oxide, and wasn't having much luck there. Don't know if I want to start with that. I might try to synthesize this compound again. One hydrogen, a chlorine, and an oxygen. So let's go ahead and start with that. Looks like I need to start by spawning a dichlorine monoxide molecule. So seems like an easy place to start. I learned my lesson yesterday, and I have a piece of paper on standby now in case I want to try to balance some reaction in my head, or want to avoid balancing a reaction in my head. So we need at least one of those, and then what would we do? I guess we would react it with water, would be my guess, to get this hydrogen, perhaps. Maybe not. Let's see. I'll spawn some waters. Typically I just, if I need water, if I need hydrogen to come out in a reaction, I just think of water as the go-to reagent. So let's see if that does anything for us. Yep, what do you know? I think this is what we want. Hypochlorous acid is what we're making. Booyah. Gosh. Came so easy. Last time I was having such difficulty with that reaction. I have no idea. But now we have two equivalents of hypochlorous acid. Beautiful. Let's continue. Now now we're getting already much more complicated, so now we're going to make, we have this moly-site reaction. First we have to synthesize, what would this be? I don't know if would you call that like di-iron trioxide or something? No, that's probably not what you would call it. I think you would, there's a slightly more complicated naming convention here, because you have to specify the valence of the iron, or essentially how charged it is. Anyway, we can try to figure this out. No matter what we're going to do, we need some iron, so let's go ahead and break out some iron, shall we? I'm going to try to load up stream on Twitch just in case someone happens to drop in the chat. I don't know if anyone will, because I'm typically not streaming for very long, but you never know. So let's go ahead and get some iron going. Let's see. I know I synthesized iron yesterday, or some kind. Here we go. Ferrous oxide. There we go. Let's see. So the reaction, the compound we want to synthesize has 2 irons and 3 oxygens. So perhaps if I get just a bunch of ferrous oxide. Let's see, we wanted, maybe if I just get a few more equivalents. Although this wouldn't work, because if I just have a group of ferrous oxide, the ratio of iron to oxygen will always be 1 to 1. Whereas equal the ratio is. 2 irons to 3 oxygens. So we need something else as well. Perhaps, I'm not sure. Could just, I could throw some water in there. Essentially we need an extra source of oxygen. So, I don't know, maybe we could just throw some more water at it. Not entirely sure if this will work. Or maybe I could just have a molecular oxygen. In this case, this might work. Let's get another oxygen out. Let's see here. Yep, here we go. Okay, I think this is what we want. Yeah, so the naming convention on the products here, iron 3 oxide is what we're synthesizing. Essentially what that means in a sense is that iron has a +3 charge, so that +3 charge multiplied by 2 is a charge of +6 in this compound, and then oxygen in compounds like this generally has a charge of -2, so 3 of those gives -6. -6 and a +6 together gives you a neutral compound, which is how that works. Let's go ahead and do this combustion. Cool. Use some crazy structures going on here. Got an oxygen with 2 bonds to an iron. Weird. What's next? Oh, that's not everything. Now we have to produce, I guess this would be iron 3 chloride, I think. Iron 3 chloride and dichlorine monoxide. Okay, so I think I already synthesized dichlorine monoxide. Yeah. So if I just get a couple equivalents of that out here, maybe I can, no? Nothing yet? How about, do I need more? Where is it? There it is. Really wish I could do more here. Okay, I think this is what we wanted. Iron 3 trichloride. Is that what I wanted? Yeah, that was it. Sweet. Iron 3 trichloride. Nice. Beautiful. I'm a real chemist now. I think I mentioned this in the last stream, but I have a minor in chemistry, and gosh, I really love chemistry, so when I saw this game on Steam, I knew I had to buy it. So let's see here. I'm gonna leave that combustion reaction alone for now. Come back to it. This Man of Fine Art sounds fun. Pretty straightforward too. I think I just have to, looks like I almost completed it last time. I just need some calcium hydroxide and some bicarbonate. So let's do that. Let's see. Calcium hydroxide. I think this is all in alphabetical order. Something like that. Yeah, I think it's alphabetical order. And what was the other thing? Bicarbonate? Or was it carbonic acid? Wait, is this I thought this was I'm not sure. Oh, bicarbonate is the ionic form of this. Okay, that makes sense. I was just calling it bicarbonate. But that's the form of this compound with the 2 hydrogens removed. So let's see. I think this is what we want. Calcium carbonate. Beautiful. Awesome. This is the compound that makes up limestone, I believe, in the structures of coral, I think. As I've mentioned previously, my marine biology is not that great. Let's see. Here we have, what would you call this? Sodium hypochlorite? maybe? I think that's bleach. This looks pretty easy. Baking. So we have spawn a sodium hydroxide, and then we will neutralize that with acetic acid, or sorry, the carbonic acid, I think, to make sodium bicarbonate, which is baking soda. So let's see here. Spawn our sodium chloride, and this game is super fun. It's so simple, but I don't know. I just love it. Let's see. I needed the where is it? Carbonic acid. There we go. I might need more than one equivalent. Oh, here. Yeah. Let's just get a couple. Does that fit there? There you go. No? Still not yet? Oh wait, I need sodium hydroxide, duh. What am I doing? Not sodium chloride. Let's see. Still trying to figure out. Okay, there we go, sodium hydroxide. And then we should be able to do the neutralization. Yep, here we go. And this is called sodium bicarbonate right here, or baking soda. And there it is. Beautiful. Wonderful. Okay, what's next? Now, we can create sodium carbonate, which, to do that, we just have to react this with another equivalent of sodium hydroxide, classic acid-base reaction. Let's see. Sodium hydroxide, where are you? Am I not able to navigate this yet? Okay, there you go. And for some reason, I still have this up. Maybe I need more sodium hydroxide. Come on. Yep, there we go. I needed 2 equivalents. Oh, so I'm just reacting the carbonic acid with sodium hydroxide. I really like how all of these reactions are nicely balanced. So essentially the number of each type of atom is the same on the left side of the arrow as it is on the right side of the arrow. So there are 2 sodiums here, 2 sodiums here, 4 oxygens here, 4 oxygens here, and that's it's obeying the law of conservation of matter. So, you know, you're learning stuff while doing cool chemistry. Awesome. Oh, we got gallium now? Gallium's cool stuff. I think it like melts at room temperature. If you like, it's like a metalloid or a metal, I think. If you hold it in your hand, it'll melt. Yeah, the melting point is about 30 degrees Celsius, which I think is pretty close to body temp. I have no idea what I'm going to do with gallium. I don't know much about the chemistry of gallium at all, but I can try something. Oh yeah, see, we made limestone. Let's see. Battle of oxide. Seems pretty easy. Or do we want to make sodium hypochlorite? Let's do that. This should be pretty easy. I think we just have to react sodium hydroxide and hypochlorous acid. Let's see. Sodium hydroxide. Where is it? There you are. Sodium hydroxide, and then hypochlorite. hypochlorous acid. There we go. I think this should work, so this hydroxide right here should grab this hydrogen to make a water molecule, and then the sodium will associate with this oxygen chlorine group. There we go, sodium hypochlorite. Pretty sure that's bleach. And here it is. Awesome. Another thing that this game is doing a pretty nice job of, I guess, there are some strange things. As you go down in the periodic table, the atoms themselves get a lot bigger, and as you move to the right across the periodic table, or actually no, that's wrong. As you move down and to the left of the periodic table, atoms get a lot bigger. As you move to the right, the atoms get a little smaller due to, well, it has something to do with a property called electronegativity, but, you know, we can get into that a little bit later. So I was just kind of curious here about relative sizes of sodium versus chlorine, but I guess that's right. So, we'll try this. We want calcium oxide and carbon dioxide to make calcium carbonate. Cool. Should have those already. No, I have carbon dioxide. Where is it? Anywhere? Hello? Carbon dioxide? I know I made you. There you are. Jesus. And the other was calcium oxide. Okay. I have that in ions. Which one's ions? No? I guess it's not an ion, it's a salt. No, do I not have it? No, I don't have calcium oxide. Can I make it? No? Not yet. So, I have to make calcium oxide first. And let's see if I can do that in... Oh man, we haven't done this one yet? Let's do that. Hydrogen peroxide and hypochlorous acid. Easy. Okay, where is it? Hypochlorous acid. My list here of compounds is getting too long. Acids, there we go. Where is it? There it is, finally. Hypochlorous acid. And what was the other one? Hydrogen peroxide. Okay. Easy. E, F, G, H. There we go. Okay. Might need... No, here it is. Water, molecular oxygen, and hydrochloric acid. Beautiful. I think I've already synthesized hydrochloric acid. Let's see here. Can make iron 2 chloride. Conduct a redox reaction with 3 different molecules to produce iron 3 chloride in water. Okay. And I assume we have to do that using hydrochloric acid, iron, and something else. That's going to be my guess. Perhaps some oxygen as well. Yeah. Yeah. So let's get some another hydrochloric acid out. We already have water, so it's a redox reaction, right? Yeah. But we need some iron, and we can just get some regular old iron out here. Let's see here, combustion, redox. No, I don't think that's what we want. Let's see here. Okay, this is a little strange. So it wants us to make iron 2 chloride, but here in this little objective, it says to produce iron 3 chloride, which is kind of weird. So let's see here. I've got my paper out. So we're going to try to balance this reaction. We want, I don't know if do we want iron 2 chloride or iron 3 chloride, because that'll affect the balance in the reaction. We'll try iron 2 chloride. We're going to make iron 2 chloride in water. And they tell us that we want 3 different molecules on the left. So what's that going to look like? I'm going to guess one of them is oxygen. So we need some kind of oxidant, and oxygen is generally a good oxidant. So we'll have that. We'll have, I don't know, hydrochloric acid and just plain old iron. Maybe that'll work. So I think we need, I'm trying to balance the reaction on paper right now. So start by balancing the oxygens, I guess, and then the hydrogens. So we need 4 hydrogens, okay, chlorines. Alright, I got it. So I think what we need is 1 equivalent of oxygen, 4 equivalents of hydrochloric acid, and 2 iron atoms. And that will give us 2 equivalents of iron 2 chloride and 2 equivalents of water. Okay, let's try that. Hopefully that'll work. So you want some molecular oxygen. Where are you? There you are. So I want 1 equivalent of that. I want some more hydrochloric acid. Hydrochloric acid. There we go. I think I have. Get another one out. Or how about I just clear the? Let's clear the space. Actually, because I've lost track of what compounds I have out. So there we go. So we'll start over. We want a molecular oxygen right here. We want 4 equivalents of hydrochloric acid. Really wish I could, get out multiple equivalents at once. So we want another one. Hopefully I'm right here. So check my phone real quick. Okay. And then we want 2 iron atoms. And with all this together, we should have all the atoms necessary for a balanced reaction. And by balanced reaction, I mean the numbers of atoms will remain constant on both sides of the reaction equation. Nope, that didn't work. crap. Maybe they want iron 3 chloride. So, let's see, I'll try that again. Make iron 3 chloride and water. I'm gonna react that with oxygen, hydrochloric acid, and just plain old iron. So to do that, we want, let's see, 2 oxygens, and then 4 hydrogens, which gives us 4 chlorines. Doesn't quite work. So then, let's try that again. And I've kind of forgotten how to balance reactions. There's a method to it, but yeah, it's not quite coming back to me yet. So let's try. I'm gonna redo what I did. This iron. No one can see me working through this right now, but perhaps you can work along at home, see if you can get it faster than I can. We want to react oxygen with hydrochloric acid and iron to make iron 3 chloride and water. Gotta balance the reaction, so let's try this again. 2 oxygens, 4 hydrogens. That gives us wrong number of chlorines on both sides. So let's see here. About let's do this. Let's do 4 there, 12 there, which means we need 4 here, 6 here, and 3 here. Okay, so I think this will work. So now we're going to try 3 equivalents of oxygen, 12 equivalents of hydrochloric acid, 4 equivalents of iron, and that should give us 4 equivalents of iron 3 chloride and 6 equivalents of water. Just double checking that everything works out here. So we have 6 oxygen on both sides. That works. We have 12 hydrogens on both sides. That works. We have 12 chlorines on both sides. That works. And 4 irons. Okay. That's a lot of reagents. So man, 12 equivalents of hydrochloric acid. Really hope this works. Not sure. I don't think there's a way to bring out multiple molecules at the same time, so we're just gonna roll with it. We have 8 right now. We just need 3 more. Okay, so we got the hydrochloric acid. I think there's 12 out here right now. We have 12, yeah. We need 2 more molecular oxygen. Here we go, 1 more. And then we need 4 irons. So we'll get out 2 more irons. Gosh, I really hope this works. All right. No? Oh, you gotta be kidding me. Dang it. 3 different molecules produce iron trichloride and water. I thought that would work. I mean, the reaction's balanced as far as whether or not it is feasible reaction, I guess that's another story. Well, how about, I'm gonna just move on for now, come back to that. Try this half-base stuff again, the iron oxide combustion reaction, where, so previously, wait a second, isn't that, okay, we can make it right here, there's iron oxide, and then combust. Is this the same thing? Wait a second. This is the same reaction under its, but it's under the synthesis portion and the combustion portion. And I guess it's kind of both. It's just a little weird. Ferrous oxide, okay, that's the actual name. I should go by the correct name. Okay, so, does that work? Okay, there we go. It's a little confusing, you have to click on the correct reaction banner to get the quest. Synthetic rust. Okay, we're going to react ferrous oxide and water, and then that should give us what we want. Okay, let's just checking the time real quick. Can't spend all day playing video games, no matter how much I'd love to. Some water, and is that enough? Do I need more equivalents? I think this is what we want. Ferrous hydroxide, right? No, we just have to dissolve it in water. Okay. There we go. Rust. Beautiful. That's the end of that branch. Man, we are making great progress. I am much more on my game than I was the other day. I was having some trouble with just basic reactions yesterday, but I'm making much more progress today, I think. I think we'll do one more reaction, then we'll call it good. So here we have calcium carbonate, or sorry, gosh, calcium oxide and carbon dioxide. Okay, do I have, wait, I was looking at this earlier and I don't think I have calcium oxide. It's a salt, I'm pretty sure. Let's see here, calcium oxide, no, I don't have it. So, means I'd still have to make, calcium oxide first. I can't just spawn it though, I don't have it. See, was I supposed to make it during the gypsy's gypsum? I made calcium sulfate previously in this previous reaction. I'm assuming that these linked reactions kind of build on one another. So maybe we source our calcium oxide from calcium sulfate somehow. Let's try another one. Alright, so previously we made sodium bicarbonate sodium carbonate, and now we're going to do a displacement reaction to produce sodium chloride and carbonate. Calcium carbonate. Okay, so that should be pretty easy. I think we just need to react sodium carbonate with calcium chloride, and that would give us our displacement reaction. So go ahead and look in a new direction. So we want calcium chloride. Where is it? Calcium chloride and sodium carbonate. I just need one of each. Let's see here. I think we need a couple equivalents. No? Is this it? Yeah, that's it. Nice. Cool. Oh, that was it? I figured there'd be more to that branch. It's just kind of off on its own. I feel like these should be connected to something else, but they're not. Okay, so the only remaining reactions are ones that I'm a little stuck on, because I can't spawn calcium oxide. So, yeah. Maybe this would be a good place to call it quits. I've done quite a bit today. We're really filling out this tree. It's looking real nice. Yeah, and this synthesis reaction is a little weird because I'm confused on whether or not they want you to make iron 2 chloride or iron 3 chloride. Oh, it's a little strange. I mean, maybe you need ferrous oxide to make this, but it's a little. I would assume that. I was assuming that I wouldn't need that for this reaction though, because it's so early on in the tree. But maybe not. Maybe I'll try that real quick. Let's see. Try to make iron 2 chloride again in water. And now we have ferrous oxide, and let's try hydrochloric acid. But we also need an oxidant, so we can try oxygen again. See, would this work? So let's see here. So gonna balance oxygens or hydrogens. So 3 oxygens there. Double that. See here. So we have 4 oxygens on both sides. We have 4 hydrogen. Oh, no, crap. We don't have 4 hydrogens. Let's try that again. So let's increase that to 4. Now we have 8. So 4 iron, 2 chlorides, and then means I need 4 of these. Then we're not balanced with the oxygens again, so it would balance that again. You'd end up with 6 hydrogens, so then you do this again. I think I'm just going in circles. See, let me try that again. I think I messed up. Oh yeah, I messed up. Whoops. I accidentally, I made a weird error. Try that again real quick. Iron, chloride, water. So, okay, start by trying to balance the oxygens, I guess. So, try 2 equivalents of iron oxide, then that means we have to add more water on the product side. So, that gives us with 2, let's see, that gives us 4 oxygens in total on the reactant side, so we need 4 equivalents of water to get those 4 oxygens on the product side. And then, so that leaves us with 8 hydrogens on the 8 hydrogens on the product side, and so we want 8 equivalents of hydrochloric acid, which means we would need 4 equivalents of is again. I don't think that works, because now we don't have enough irons. So then increase that again to 4. Then you have too many oxygens. So you have 4, 6. So then raise this to 6, and you have 12 hydrogens. So then you have to increase the amount of hydrochloric acid, which means you then have to increase the number of chlorines, and then, you know, it just doesn't work. You go in circles. So yeah, increase the chlorines to 12, and so you'd have to increase this to 6. So then you have 8 oxygen, so then you'd have to increase this to 8. And then that means you'd have 16 hydrogens on the product side, so then you'd have to increase the equivalence of hydrochloric acid to 16. And then, yeah, that doesn't work. Yeah, it's just not going to work. So, how about I just leave it there for today? I'll come back next time and tackle this synthesis reaction. If you made it to the end of the video, thank you very much for watching, and please take a moment to subscribe to my Twitch channel, Miles Does Science. There's a big purple follow button probably at the bottom of this video on the right hand side. If you click that, I'd greatly appreciate it, and the subscriptions are free, and you can always unsubscribe later if you want. Thank you very much for watching this video, and have a good rest of your day. Make sure that I don't lose my save there. Goodbye.